In this video, I'm going to go over the solutions for the problem set 5.1, questions 12 through 15 found on page 178. So number 12 talks about calculate the molar enthalpy change from the data in figure 5.9, and they've got a graph of some zinc when it was first added to the solution at room temperature, approximately 20 degrees, and then the copper sulfate is added. So the curve goes up and eventually reaches a maximum temperature of 61 degrees and starts falling off again. So some information they give you is that the copper sulfate is 1 molar and that you're using 1 liter or 1 decimeter cubed of it. So that's 1 mole of CuSO4 used. And then they give you also in the graph, they give you the beginning temperature of 20 degrees for the zinc, and then your maximum recorded temperature was 61, but the extrapolated temperature, which would be more accurate, is 70 degrees. So for my problem, I went ahead and used 100 gram or 1,000 grams for my mass because I've got a liter of water, and I used 4.18 because I'm assuming the solution's the same as the specific heat of water. And then my temperature change, I went ahead and used 50 because I took 70 minus 20 instead of 61 minus 20. So your answer will be slightly different whether you use the 70 or 61. So that gave me an answer of 209,000 joules. And then they wanted it expressed as kilojoules per mole. Well, that's 209 kilojoules. And since it was 1 mole of CuSO4 used, it is 209 kilojoules per mole. And then the last thing is to decide, was the heat being gained or lost? And because the temperature went up, it's heat loss, so I should express this as a negative 209 kilojoules per mole. Number 13, this is basically the information they gave you, the initial temperature, the final temperature, and then the concentration of your NaOH and HCl. Now in the book they have a mistake because they've got the concentration listed as KOH and HNO3, but you have to have the same reactants and products. So if you have volume for HCl and NaOH, then we should have concentration for those as well. And what's important to realize is that HCl and NaOH will neutralize one another, and they'll do it in a one-to-one fashion. You'll end up with NaCl and H2O. And it's important to know it's one-to-one because I don't have the same amounts. I've got the same volume of each one, but I've got slightly different concentrations. So that means the one with the weaker concentration, the NaOH, is going to be my limiting reactant, which I'll need to know when I figure out the kilojoules per mole. So in the meantime, to get delta H, I can go ahead and take the mass. I have to add the two volumes together. We're talking 100 grams mass, the 4.18 using water specific heat. And then the temperature change, the 32.3 minus the 24.5, it's going to give me a temperature change of 7.8. And so my delta H is going to be 3,260 joules. Or looking at my sig figs, I could round that to 3.3 kilojoules. And then when I look at it as far as moles, since the NaOH is going to be my limiting reactant, it's 9.50 moles per liter. That's the concentration. And my volume, 50 milliliters, is really 0.05000 liters. So my molar amount is actually 0.04750 moles. So I can go ahead and take the 3.3 kilojoules, divide by the 0.04750 moles used, which I have way more sig figs on my moles than I do on my kilojoules. But when I go ahead and divide that, I'm going to come up with a negative 69 kilojoules per mole. And again, I realize it should be a negative because neutralization is an exothermic process. And the number 13 wants to know what assumptions were made in this. We're assuming that there was no heat loss to the surroundings, that they completely reacted, that the C value and the density of the solution are the same as they are for water. Number 14 wants to know, calculate the enthalpy change that occur when 1 mole of the solute is added to 1 liter of water. So in other words, they want to know what the molar heat of reaction is. So I'm told that I have 5.350 grams of ammonium chloride added to 100 milliliters or grams of water. I've got my initial and final temperature. So when I plug into MCAT, I could just plug in 100 times 4.18 times 3.76. Or if you want to go ahead and add the 5.35 grams to it and make it 105.35 grams, you could. Typically, we just use the mass of the water when we do this. So doing it the way we typically had, I would take 100 times the 4.18 times the temperature change here, which is 3.76, it looks like. And I come up with a heat loss of 1572 joules. Actually, is it loss or is it gained? The temperature actually decreases, so this is actually heat being absorbed. So this is going to be a positive value this time. And then when I change that would be 1.57 kilojoules. And then to come up with my molar amount, I have 5.35 grams. And the molar mass, when I look up for, let's see what my solute was here, ammonium chloride, so NH4Cl, 1 mole of that is going to have a mass of 53.5 grams. So we're really talking about just 1/10 of a mole. And so when I come up with the kilojoules per mole, so I know 1 mole in 1 decimeter of water, that would be 1.57 divided by the 0.10 moles, and I end up with 15.7, and again it's going to be a positive because the temperature decreased, showing heat was absorbed, kilojoules per mole. And number 15 is just asking for some terminology. They want to know what delta H means. It means the change in enthalpy or heat or energy of a system during either a physical or a chemical process. So a physical process could just be a change of state or solutions. Chemical process could be combustion or neutralization. But again, it's almost impossible to measure the total enthalpy or energy of a system, but we're pretty good at measuring the change in energy during a reaction or a process. And it's measured most often by using mass times C value times temperature change. And as far as in a lab, that would be done using a calorimeter and some other pieces of equipment to come up with those measurements of mass and change in temperature.